Now let's go into the second objective, that is finding solutions in an interval for a trigonometric equation in factor form. So first off, what we have to do or understand is what is a factor form of an equation. And you know this already. So if I give you a general equation without any factorization, it looks like this. When we factorize it, we have it in a product of factors, okay? Or a product of binomials. And they look like this. So this is a factor form. And what do we, or why is this a prettier shape to find the solution of an equation? Because when we have a product of things like here, we know, and we particularly we're working with equations equal to 0. So we have this form, we know that a solution is when either this is 0 or this is 0. So what we usually do is this equation is 0 when this factor is 0. So I have to check where that factor is 0. So in this example, this factor is 0 when x equals 3. And this factor is 0 when what? When x equals minus 1. And that is what it means to have two solutions for an equation, or two solutions from a factor form, is when I have a product of two things. For this product to be 0 is because one of these things has to be 0. So I have to check where each of those things is 0, and both or all of the solutions that I find are going to be my possible solutions for this equation. So what we're going to use for this objective is this notion of when I have a factor equation, that is equal to 0, the solutions are all the zeros from this factor and the zeros from this factor. And moreover, in these exercises in Alex, you're not going to use calculator. That is, all of these exercises can be solved with the values in the unit circle. So you can have your unit circle at hand, but because I know that you are good at it, you can also use your hands, okay? So if you don't remember how to use your hands, I strongly suggest that you practice or check out the previous videos, and you can have your unit circle at hand for this video, okay? Either way, I'm going to have it up here in my exercises. So this is my first example, or must be my first exercise. So I'm being asked to find all my solutions, positive solutions in this interval for this factored equation. So, and write your answers in radians in terms of pi. So that is our first clue that we're not going to use calculator because it specifies that it's in terms of pi, and we know that the calculator gives us the product with pi included, okay? So, again, this is an equation that is already factorized. So an equation, or this equation, is going to be 0 if my first factor is 0, or if my second factor is 0. So each of these terms is going to give me a solution. And if we think about all the exercises we did previously, how many solutions is each factor going to give me? Here's a hint. How many solutions can a single trigonometric equation have? That's it. It can have at most 2. So that means that each of these factors is going to give me at most 2 possible solutions. So in total, I can have at most 4 possible solutions, okay? It doesn't mean that I'm going to have 4 always. It means that I can have a lo más 4, a lo menos 0, and we're going to see why. So when we go from a factor equation into the sub-equations for each factor, everything turns into a simpler solution. So let's proceed. So for this factor to be 0, I have to solve for cosine. So this level of despeje may sound complex, but it's the same despeje that you've been doing your entire life. So to get rid to find the value of theta, first off, I have to get rid of everything that is affecting the term that has the theta, that is cosine. So the first thing that is getting in my way, como siempre despejamos, is things that are adding. So in this case, I'm going to subtract a square root of -2 on both sides of my equation. Theta. Then I have a 2 multiplying my cosine, and I want to leave my cosine alone before I apply an inverse function. ¿Ok? Ojo, es como si ustedes quisieran hacer esto, and I ask you to find the value of the square root of 2. No pueden hacer esto to get rid of the square root. You have to first, what you have to do first is leave the quadratic, or más in the square root alone, and then you raise to the power of 2 to get rid of the square root, okay? So the exact same thing is going to happen when you're trying to solve more complex equations, okay? Make sure to, before applying the inverse function, your trigonometric expression is completely alone, okay? So lastly, cosine of theta, I'm going to divide my entire equation over 2. So my cosine of theta is completely alone. And there I have this final solution. Ahora, I told you, Alex is not going to allow you to use calculator, but you already know this answer. Because you know what angle gives you a value of theta, más bien, gives you a value of cosine of square root of 2. If you use your hands, you know that the middle finger, if you select the middle finger, that is the angle of pi fourths, you know that cosine of pi fourths is the square root of 2 over 2. But I don't want a positive value, I want a negative value. So let's go here in my unit circle. Where is cosine negative? We know that because cosine is x, cosine is negative in these two quadrants. And which angles in those two quadrants give me a value of cosine of minus square root of 2 over 2? 3 pi fourths and 5 pi fourths. That is the two angles in this quadrant and in this quadrant that have a reference angle of pi fourths. So my solution for this equation is these two angles. The angle 3 pi fourths. So my first solution is 3 pi fourths and 5 pi fourths, okay? So those are my two possible solutions for this expression. O sea, you could have also do the apply the inverse function. Theta es igual a cosine inverse of minus the square root of 2 over 2. And plug this into the calculator, but remember, you're not going to use the calculator in Alex. So it's better if we leave it at here, because all of these values, you already know them, because we're only going to use things that are in the unit circle. So you can have or deduct the logic from this step, okay? So we're going to do the same thing with my second factor. And my second factor was the sine of theta plus 3. So remember, I have to leave my sine completely alone. So sine of theta equals minus 3. Now, here's when things become interesting. Let's look at the unit circle. Is there an angle that, when I evaluate it in sine, gives me minus 3? No, exactly. The biggest value the sine has in the unit circle is minus 1. So there's actually no solution for this factor, okay? So this factor can never be minus 3. So at the end, as a final solution, I'm going to put all my possible solutions that I found together. So all my solutions are only the first two. 3 pi fourths and 5 pi fourths. And I don't have any more solutions from the second factor, okay? So that is it. Okay? relajen la raja. This is easy, okay? Next example. Right here. I have this second question, and again, I'm not gonna use a calculator. I'm gonna do this by hand because that is how Alex asked us to. So I know that the answers for this equation is that any of these factors have to be 0. So I have to check where each of these factors turn into 0. So I'm going to start with the second one because I can. So to do this, first I have to leave my sign alone. To leave my sign alone, first off, I have to get rid of the square root of 3 that is subtracting on this side. So it passes adding. And then I have a 2 that is multiplying, so I have to divide my entire equation by 3. There we go. So we have this number, sine of theta equals the square root of 3 over 2. And if you look at your fingers or look at the unit circle, you know that sine of theta, or the reference angle that gives me this value of square root of 3 over 2 is, check out your fingers, exactly, pi 6. The reference angle that gives me this solution is pi 6. Pero again, remember, this equation can have 2 solutions because sine is positive in 2 quadrants. Which quadrants? 1 and 2, because sine is y. So my solution is not going to just be this reference angle, but the other angle that is in quadrant 2 that has the exact same reference angle. That is 5 pi 6. Okay? So here are the 2 solutions for my second, I'm going to erase all the garabatos that I did right here. So this is the second solution for my equation. Let's do the other one. 2 cosine of theta equals 1. So cosine of theta equals 1/2. So look at your hand and tell me where cosine is 1/2. So if you look at your hand by some time, you can identify that theta, the reference angle that gives me the solution, or look at your unit circle, is pi thirds. Cosine of pi thirds is 1/2. But again, cosine has 2 places where it is worth 1/2. Where this is a positive value, where is cosine positive? In quadrants 1 and 4. Entonces, my possible solutions are pi thirds and 2 pi minus pi thirds. Why? Because remember, I cannot have negative answers because it would be easier if I just selected this angle pi thirds and the negative angle that goes the other way, minus pi thirds, right? That would be easier because I only want positive answers. So my answer has to be a full spin minus the reference angle. The reference angle is pi thirds. Or you can just look right now at your unit circle and identify that my other solution is 5 pi thirds. So this is pi thirds, 5 pi thirds. And there we go. So all my possible solutions are pi thirds, 5 pi thirds, this is 3, pi 6, and 5 pi 6. So these are all my possible solutions. Okay, let's continue with the examples. Okay, by now you know the idea. We have 2 factors, so I have to check which where each of my factors are 0. So here are my 2 factors. Square root of 3. I have to equate them to 0 and now solve them. I'm going to start with the first one. Why not? So first off, I have a cosecant of x. So if I want to solve for cosecant, this is cosecant of x equals 1/2. And then if you don't want to think about cosecants, you could just flip it to rewrite it in terms of sine. So if I flip my entire equation, I know that the flipped or the reciprocal of cosecant is sine, and the flipped or reciprocal of 1/2 is 2. So my question is the following. Let's go into our unit circle, and you tell me where in my unit circle is my sine 2. Exactly, nowhere. So this equation has no solution. Let's check the other one. So I have a secant, so I have to leave it alone. So I have 3 times the secant of, I'm going to pass this to the other side, minus 2 the square root of 3. And then I'm going to divide my entire equation over 3. So this is 2 square root of 3 over 3. Now, I don't like seconds because I'm better at thinking in cosines. So I'm going to flip my entire equation. So the flipped or reciprocal of secant is cosecant, cosine. And the flipped of this number is 3 over minus 2 the square root of 3. That's it. And you're going to say, Andrea, where am I going to find this in my unit circle? And I'm going to tell you, chill. Let's rationalize this. So I'm going to multiply by 3, both in the numerator and my denominator. So this is actually 3 times the square root of 3 over minus 2, and, ojo, square root of 3 times the square root of 3. Esto es the square root of 3 al cuadrado, o sea, hace 3. See, so this is minus 2 times 3. I just multiplied this by this and this by this, okay? So if I simplify this, I have a 3 in my numerator and a 3 in my denominator, so this is minus the square root of 3 over 2. ¿Qué pasote? Just to get 2 minus the square root of 3 over 2. So if you remember, and if you look at your finger, there is an angle that gives you the square root of 3 over 2. And if you remember, that would mean that you have to have 3 fingers to the left. Sorry, see? To the left. So that means that your angle is pi 6. So you know that the reference angle pi 6 gives you square root of 3 over 2. But where is cosine negative? Cosine is negative in my second and third quadrants. So I have to choose the angles that have as reference angle pi 6, but live in the second and third quadrant. And those angles that live in the second and third quadrant and have a reference angle of pi 6 are 5 pi 6 and 7 pi 6. So my answer for this equation is 5 pi 6 and 7 pi 6. Okay? Or again, if you want to be lazy at the beginning, just go ahead and look in your unit circle where the values for cosine, o sea, for x, remember cosine equals x. So where are the values of cosine? Minus the square root of 3 over 2. Okay? So at the end, all my solutions are just the solutions of the second factor. Okay, it's just 5, 6 over 7 pi 6. And that's it. Okay, let's do another one. So I have 2 factors. Secant of theta equals 1. Plus 1 equals 0. And 2 sine of theta minus 3 equals 0. So I'm going to start with this one. So if I solve for sine, this is sine of theta equals the square root of 3. And then I divide my entire equation to get the square root of 3 over 2. So again, remember, I'm going to have 2 solutions, and those are the 2 solutions where sine gives me a positive value of square root of 3 over 2. If you look at your hands, that would mean that you would have to have 3 fingers to the right. So if you check what finger that gives you, it gives you the, well, depending on your hand, I'm using my right hand, so that gives me the ring finger. So the angle or the reference angle that gives me square root of 3 over 2 is pi thirds. But that is not the only angle that gives me a value of square root of 3 over 2 in sine. If you remember, sine is positive right here and right here. So I have to take those angles that have the exact same reference angle, pi thirds, because those two angles are going to have, so this one and this one have the exact same reference angle, and the value for those two is pi 3 over 2. So the possible solutions are pi thirds, the reference angle, and half a spin minus pi thirds, o sea, hace 2 pi thirds. So this is the solution for this side. Now, let's go to this side. This is secant of theta equals -1, and then I'm going to flip it. The reciprocal of secant is cosine, and the reciprocal of -1 pues is -1, because -1 is -1 over 1. If you flip it, nothing happens, and it doesn't matter if your sign is in the numerator or the denominator, okay? So, let's think about cosine of theta equals 1. If you think about it, there is only one place where cosine is -1. I'm going to give you a second to think about it, or to look at the unit circle that we have up there. Yes, my solution is pi. So the only solution for this angle, for this equation is pi. So check this out. I have at most, I have 3 solutions, that is less than 4. So my solutions are pi thirds, and 2 pi thirds. It doesn't matter the order, okay? Let's go into another example, and you cannot cheat, so I'm going to raise the solution. So I'm gonna have the unit circle up here if you need it. So again, I have two arguments. Oh, you're gonna say, what happens here, Andrea? It happens the exact same thing when you have x times x minus 1. What do? You do x minus 1 equals 0, and then you do x equals 0. Okay, so the same thing is going to happen here. This factor right here, we're going to equate it straight up to 0. So this is, boom, an answer straight away. And the other factor is tangent of x minus the square root of 3 equals 0. I'm going to start with, well, I guess this one. It doesn't matter with which one you start, okay? So if I solve for tangent of x, this is the square root of 3. And you're going to say, Andrea, what the hell? And I'm going to tell you, don't despair. If you look at the unit circle, you will see that whenever you have a coordinate that has a square root of 3, it's actually a square root of 3 over 2. And the other coordinate is a 1/2, like here. Like here, one coordinate is the square root of 3 over 2, and the other one is 1/2. One is the square root of 3 over 2, and the other one is 1/2, etc., etc. So, moreover, you know that tangent is sine of x over cosine of x. And this has to be the square root of 3. And I'm going to give you like a straight up hint, o sea, like an adult version of the ladle sandwich, or an obvious solution. Whenever you have a tangent or a cotangent, if you have the square root of 3 over 2 over 1/2, this is always the square root of 3. And if you have 1/2 over the square root of 3 over 2, this is always 1 over the square root of 3, or 3 over the square root of, no, más bien, the square root of 3 over 3, ¿ok? O sea, son leyes del sándwiches como basic that you will have to know, ¿ok? So, what I'm looking for is where sine is the square root of 3 over 2, and where cosine is 1/2. So if I go to my unit circle, or if you can remember, I need sine to be square root of 3 over 2. In your hand, that means you will have to have 3 fingers to the right and 1 finger to the left. So that means that we have the pi third finger, or aquí. Square root of 3 over 2 over 1/2 equals the square root of 3. So one of my possible solutions is pi thirds. But ojo, I have to have the both solutions, más bien, the two solutions where tangent is positive. And you know that tangent is positive in this quadrant and in this quadrant. So I have the angle that has this angle of reference, and I have to have the other angle that lives in this quadrant and has the exact same angle of reference. And that angle is 4 pi thirds. So my other solution is 4 pi thirds. Let's go into the other equation. Cotangent of x equals 0. If you want to rewrite it, you could actually do the reciprocal. No, we cannot do the reciprocal. That would mean we have to divide over 0, so that cannot happen. Remember, you cannot never divide over 0. So this is cotangent is cosine over sine. And this is 0. And if you remember the Mate 3 irrational functions, for a fraction to be 0 is because the numerator is 0. Why? Because 0 over something is 0, but you cannot never, never, ever have a division over 0, okay? Remember, that is where the vertical asymptotes are, okay? So for this fraction to be 0, that can only happen if cosine is 0. So, where is cosine 0? Here and here. So my possible solutions are pi halves and minus pi halves. So my total solutions are pi halves minus pi halves, pi thirds, and 4 pi thirds. Perfecto. Let's go into one last example. Again, I have one factor that is cotangent of theta minus the square root of 3 equals 0, and another one that is cosecant of theta plus 1/2 equals 0. So let's see the first one. Cosecant of theta equals minus 1/2. And I don't like to think in terms of cosecant. So this is, I'm going to flip it, sine of theta, and I'm going to flip 1/2, and this is minus 2. So what do you think is going to happen here? Is sine minus 2 anywhere in the unit circle? No. So this is no solution, no quiero. Then I have cotangent. Let's go into this factor. Cotangent of theta is the square root of 3. And again, it looks a lot of similar like this. Okay? So let's work that logic again. Cotangent is cosine of theta over sine of theta. And this is the square root of 3. This means that cosine, por el acordeón que les di of ley del sándwich, that means that cosine of theta will have to be square root of 3 over 2, and sine of theta has to be 1/2. So this fraction, or this sandwichote, is square root of 3 over 2. So I have to check where x is square root of 3 over 2 and y is 1/2. If you look at your hand, that would mean that cosine, because cosine is the square root of 3 over 2, you would have to have 3 fingers to the left and 1 finger to the right. And that gives me the angle pi 6. So my angle of reference that gives me this solution is pi 6. Okay, vamos a dibujarlo aquí. So here's my angle. This is pi 6. And I know that here in this quadrant, cotangent is positive because it's positive over positive. In which other quadrant is cotangent positive? Right here, because you have minus over minus, so positive. So I know that the other solution that I'm looking for is right here. And this other solution, even though my picture clearly doesn't show, has the exact same reference angle of pi 6. Excuse me for my ugly drawing. So this angle is 1/2 a spin plus pi 6. O sea, 7 pi 6. So my other solution is 7 pi 6. So all my solutions are just pi 6 and 7 pi 6.